I am going to start with 13-5 from the very beginning. I lost my internet, Fios went down, and it didn't come back till after 9 o'clock for me. So I'm going to start from the very beginning. We did complete part 1 of the exercise, but I'm going to start from the very beginning. Outdoor Luggage makes high-end, hard-sided luggage for sports equipment. Data concerning 3 of the company's most popular models are below, and there's the Ski Guard, the Golf Guard, and the Fishing Guard. If we assume that the total time on the plastic injection molding machine is the constraint in the production process, how much contribution margin per minute of the constrained resources is earned by each product? Okay, so in order to do that, we're going to look at the Ski Guard and calculate the contribution margin. So for the Ski Guard, the contribution margin is $140. Using the molding machine process, we are going to calculate the contribution margin per the unit of the constrained resources, which is the molding machine time. So it's given to us in the problem for the Ski Guard. You use the molding machine for 2 minutes. So we would take $140 divided by 2 minutes, gives us $70 per machine minute. For the Golf Guard, we calculate the contribution margin to be $160, and the machine time is $5 per minute. So the contribution margin per the machine time is $32 per minute. For the Fishing Guard, the contribution margin is $200 and the machine time is 4 minutes. So 200 divided by 4 minutes is $50 per minute. So that answers requirement number 1. What product offers the most profitability use of the plastic injection molding machine? And you can see this based on the contribution margin per minute for the molding machine, and the Ski Guard is the most profitable. Now in requirement 3, if we assume that a severe shortage of plastic pellets has required the company to cut back its production, so much that its new constraint has become the total available pounds of plastic pellets, how much contribution margin per pound of the pellets is earned by the contribution margin, how much is earned by each product. So let's look at that. And again, we are going to calculate the contribution margin, and the contribution margin does not change from the first constraint, but this time the constraint is the number of pellets, the pounds of pellets used. Well, for the Ski Guard, it's the $140 contribution margin. The number of pounds for the pellets is $7. So if you take 140 divided by 7, that's $20 per pound. And do the calculation for the Golf Guard, is the contribution margin is 160, and the number of pounds used is $4. So then the cost per contribution margin is $40 per pound, and the Fishing Guard is the 200 divided by the 8 pounds, which gives us $25 per pound. What product offers the most profitable use of the plastic pellets? And in that case, it is the Golf Guard, because they actually have the highest contribution margin per the pounds of pellets used, the plastic pellets. Requirement number 5, which product has the largest contribution margin per unit? Why would this product be the most profitable use of the constraint resources in either case? And the Fishing Guard has the highest contribution margin. However, one of the considerations is the number of pounds they use in using the plastic pellets, and they use more of the resource, and consequently that reduces their price per the resource. When you're using the pellets, the plastic pellets, it's it's in the middle, it's $25 per pound. And when you look at the Fishing Guard in relation to using the actual machine hours, or machine minutes, again, they use a large amount of minutes, which lowers their contribution margin per the minutes the machines are used to actually mold the luggage.